Howdy everyone, this is Ari Danish with Side Effects, and today I'm going to talk to you about PDG, specifically a conceptual introduction. So PDG is a new initiative from Side Effects that has many potential applications. Inside of Houdini, you can think about wedging particles, doing them in parallel, and then, compositing them together, or creating and updating a city on the fly, creating endless landscapes, or parallelizing sequential workflows. Outside of Houdini, well, you can do things like a photogrammetry pipeline, assembling characters, doing some machine learning, or automating and scaling entire pipelines. So what is PDG? Well, it stands for Procedural Dependency Graph. It describes complex dependencies visually with nodes. It transforms that dependency description to a set of actionable scheduled tasks, and it distributes those tasks with the help of a scheduler and computes them in parallel. And if that did not make sense to you, this video is just for you, because this lecture introduces PDG without using PDG. It's conceptual. We'll use an analogy. What do humans do in their ordinary lives? Let's look at an example. We are going to use my wife assembling our wedding invitations years ago. I created the artwork, cut the doilies, bought the end caps, sent Illustrator files to printers to print, created a mailing list and printer labels. And then what happened? I was sent off by Side Effects to teach somewhere, leaving my wife alone to assemble. So this wasn't a simple invitation. We had a Ren Fair wedding. So we made scroll invitations. So we had to buy these doilies, we had to buy the sticks, this irregular length invitation. We had to glue it to the sticks. We had to, roll it up. These doilies had to be put into the end caps and glued together. Then the twine had to be done, and then everything had to be put into the mailing tubes. You get it. It was a complicated operation. So really, what did my wife have to do? Well, she had to glue the end caps into the doilies. She had to glue the parchment to the doilies, cut the string, roll up and scroll the tie with the string, so forth and so forth and so forth. All these things were functions that she had to do. And at each step of the way, she got certain results. Like she was able to get the end caps onto the doily. She was able to wrap the string around the whole scroll. She was able to create the RSVP and so forth. These were the results. These were the functions. It was not a hard process, but she had to repeat this 500 times. We had a big wedding. So we needed to automate. And we always had this functionality in Houdini and outside of Houdini by either shell scripts or Python scripts, right? Here's our shell scripts. We even have all these Houdini command line applications that you can use, or you use Python scripts. And inside of Houdini, we have the wonderful for each loop where we could say, glue the end caps to the doily, glue the scroll to the doily, wrap it up, and we could do this as an iterative process over and over again. And even outside of Houdini, there's these great applications, right? Like Automator for Mac, where it's doing the exact same thing. It's taking that function, okay, and it's returning a result. And then it's going to another function, taking that result, putting it into another function, and creating a result, and so forth and so forth. Even on iOS, if you have an iPhone or iPad, there's an application called Shortcuts that does the same thing. But can you notice this trend? It's very linear. You take one thing and you do the next thing. It's a one-for-one relationship. Function, result, function, result. So what differentiates PDG? Well, if we look at a standard SOP workflow, it really is very much the same as what we're talking about here, where we have a function, it returns a result. That result is then fed into another function and returns a result, and so forth. Right? So here we have a grid function. It creates a grid. It returns a grid. And that grid is then fed into the mountain SOP, which applies a noise function. And what we get is returned one tweaked grid. And that's kind of the key here. We're going to say one tweaked grid. So one-to-one mapping. So PDG replaces that one-to-one processing of a function and replaces it to one-to-many processing. If you're a programmer, you can think of it, functions become classes or objects. If you're not a programmer, think of it as each process, each node becomes a template where many instances of a function can be spawned off. So one single instance can become one to many instances. It can be done statically. In other words, predefined. I want 10 instances to be spawned. Or think of raindrops, where you could say that I have a particle sim and it's going to be dropping particles onto the water. We might know that we want 50 raindrops per frame to be dropped, but once it bounces off the water, how many are going to be spawned to make the secondary drops? We don't know beforehand. So we can even handle the dynamics of, I do not know beforehand how many particles are going to happen, just spawn those instances. PDG creates a very flexible template that allows many different logic flows to be expressed. So let me show you that same mountain stop as a PDG network. Well, we would create two HDAs, one to make the grids and one to make the mountains, i.e. the noise. So again, here we have one class, or you can think of it as one template, and we predetermined that we want 10 grids to be made. So from that, it's going to spawn automatically 10, and if you have enough cores, parallel processes to make 10 grids. Those 10 grids, or the results of those 10 grids, is going to be fed into the next processor to make the mountains, the noise. And it's going to spawn another 10 processes to make those noise, and the results will be the tweaked grids. So again, before we had functions, now we have processes, or if you want to think about it as a class. And it returns a result that goes downstream. So back to my wife assembling our wedding invitations years ago. So we talked about all these functions, returning results, and going back to the next function. How would this look as a PDG network? Well, imagine if my wife threw an invitation party, but if from my family of only 3 people here in LA. So these 3 people would have to be scrambling to do many things, but we could already start breaking them up into parallel processes. So one person could go to the store and acquire the end caps, another one the doilies, go to the printer, and the third person could go to the printer and get the invitations. Then once those processes are done, we could reassign that person to glue the end caps onto the doilies and so forth, or stuff the RSVPs into the envelope. So each of these things are a process, or what we talked about in programming, like a class. And it returns a result. The end caps are now available, or the doilies are available to be fed into the next process, which is in this case the glue end caps onto the doilies, which returns into a result of the end caps plus the doilies, which can be then fed into another process. As you can see, this will be much faster than my wife doing everything alone, one step after another. But what happens if someone gets lazy and does not cut the string, for instance? The process breaks down. So that's where my wife checks what tasks are ready to be performed and assigns people to work on them. She becomes the scheduler. She's the one who makes sure that this is running smoothly. As a public service announcement, PDG ships with a few schedulers. When you drop down a top network, you'll get the local scheduler, which is a scheduler for a single machine. But we also have our own HQ scheduler built in, as well as Tractor Scheduler and Deadline Scheduler. Or if you know how to write Python, you can write your own scheduler. So congratulations are in order. We have made our first PDG graph. All the PDG graph is about processes being fed into other processes, returning results, and so forth, with the scheduler making sure everything is performing as needed. And let's just take a look quickly at what it will actually look like in a PDG standalone application or in a top network. Again, we have processes here that go and feed into other processes and so forth. So what really happened in my wedding invitation making? Well, think big fat Persian wedding. My wife's family is huge. They took over everything as far as the invitations go. Think about 50 people working on it. So now we had more than enough people to have multiple people doing every single task. So we could start, like the glue the end caps onto the doilies, make this into parallel instances of the same process. Now 5 people are going to be working on taking the end caps and gluing them onto a doily. And obviously, they're not dependent on each other. they can work completely independently of gluing that end cap onto the doily. So these are people, and we call them in PDG work items. So what is a work item? Well, it's just an instance of the process, an instance of glue end caps onto the doilies, or an instance of cutting strings. The scheduler is still doing the same thing, but now it's scheduling a lot more people to do, or a lot more work items to be processed. So what does that look like in PDG? Well, here I have a wedge that's going to create 3 instances of some random numbers. And those 3 instances want to be brought out into 4 more instances of orbit suction. So you can see that this is a particle simulation. So now I got 3 times 4 wedges. So suddenly 12 work items are being instantiated and processed on. And then I'm going to take those 12 work items and feed it into ROP geometry. I want to save my BGOs, for instance, to the hard drive for 10 frames. And suddenly, if I have enough cores or if I'm working on a farm, I can instantiate 120 processes at the same time. I just feed them on, and I could also collect them, and you can see I went from 120 to 40 here and so forth. So these dots in our nodes represent those work items. So let's focus on this process, glue scroll onto wooden ends. For this to happen, there has to be enough end caps glued to doilies and enough invitations for it to actually do its job. So we can say that there's a dependency of this process based on, is there a glue end cap onto doily, i.e. the result end capsless doilies, and is there an invitation ready for me to then glue the scroll onto the wooden ends? If there is, I can actually do my job. I could actively be processing that work item. If not, that work item is backlogged. I have to wait for supplies. So, it would be nice for everything to be running all the time, but we got to keep again our schedule to see, do we have dependencies? And if we do have those dependencies, are they available for us then to do the process? So this is what it looks like in PDG. So if a work item is being processed, it's bright green. And if it's ready, finished, and we have a result, it's a dull green for cooked. And finally, if it's kind of this grayish color, it means it's backlogged. It's waiting for either upstream results, or it's waiting for a core that's available to be used. And then on here, you can see that we have 3 numbers. These are the work items completed, the work items cooking, and the work items being backlogged currently. So in reality, work items have 4 states. They can be completed, they can be processing, i.e. cooking at this time. They can be a backlog task because upstream results are not ready yet, or they can be a backlog task because no cores are available to process. Finally, PDG has what's called a task graph, and I think this is one of the most powerful functions inside of PDG. So basically what it does, it's an auditor. So I could click on a work item and see exactly where the results came from in another work item upstream and follow it all the way to basically the genesis of this whole workflow being created. So why is this so important? Well, what happens if you're not getting the correct results? Or if certain cores or processes are erroring out? This is an easy way to follow step by step the processes to see where the problem is occurring. And here's what it looks like in an actual PDG network. I clicked on this partition by attributes, and you can see the partition by attributes is going to take 3 work items here and put it into one partition. So I can actually follow that line and see, hey, it's affected these 3 work items, and these 3 work items were generated from the results of these 3 work items in the ROP geometry generated particle streams. And those 3 were generated from these 3 work items in the wedge orbit section, and so forth, finally to the genesis at the wedge the birth seeds. But in reality, one work item can be dependent on hundreds or even thousands of upstream work items. So in this case, I selected FF MPEG encode video. The whole function of this top is to be able to take upstream frames that have been rendered and make an MP4 video out of it. So obviously, it is dependent on all the frames being rendered from at least Mantra. Okay, and then in this case, what we're doing is we made 3 wedges of each of the particle streams, so we could do a composite and overlay them to make one smooth particle stream. And that's what this first ImageMagick is doing here. It's just taking those 3 wedges and making a nice composite overlay. And then the other thing we're doing here is we've got another ImageMagick that is going to go and take those overlays. And if you notice here, I didn't know exactly what would look best, so we created 4 wedges of different orbit sections in our particle curve force to see which section would look best. So I wanted a mosaic of that, and that's what the second ImageMagick is doing. So we have to wait for all that to be rendered and then composited and then made into a mosaic before we can make the MPEG video encode. So we can see that one work item can be dependent on hundreds of different work items upstream. In the other case, here I selected partition by frame, which is only dependent on its upstream values. And you can see it's not dependent on everything being completed because each work item in the partition by frame is looking for different orbit streams of that wedge. So in this case, there's only 4 work items that it's going to backtrack to here and go upstream from there. And then for each of the 120 frames going down for the ROP geometry and the ROP frame for it to render out each of those wedges. But what's really cool, if you notice, is in this case when I selected partition by frame, it not only told me what work items it was dependent on, but it showed me where the results are going to go to. So here, one result is going to the ImageMagick for doing the mosaic, and then it's got to wait for all the other stuff to be finished, and it's going to be part of the final video. Besides the task graph, we also have the task info panel. So you could go and click any work item and either right click and say task info or just hold down the middle mouse button and you get all this information about that specific work item. For instance, all the attributes that were generated, what type of attribute, is it a float, is it an integer, or is it a string, its outputs, and so forth. And if there's problems or any messages or warnings, we also have a button to say show the log. And here's the log file for that work item, and you can follow it up to see if there's any errors and where that error occurred. So before finishing this tutorial, this lecture, I want you to think about how you can use PDGs in your everyday life, like a kitchen remodel. Now, how can you take something that would be very tedious one step at a time and divvy it up amongst workers? Or a ski vacation to the Swiss Alps. Imagine you're Kim Kardashian with all her assistants. How would you make a luxury trip? Or throwing a simple birthday party for your kid. These are all things that can make you mentally focus into how to create PDGs. In conclusion, PDG allows you to use that familiar Houdini network workflow that you love to create with to create highly flexible and scalable data flows. And on a personal note, we've created several introductory PDG tutorials to get you up quickly to speed. I hope you follow these hands-on tutorials and enjoy using PDG. I'll see you in the next tutorial.